Okay, so these 3 points are on the curve we're looking for, and we got to put it in this form. So knowing we're going for that form, plugging in what we know, well, as a bunch of ordered pairs here, we've got a lot of x and y values to work with, right? So maybe what I should do, knowing that I'm going for an equation in the form of y equals ax squared plus bx plus c, I should start substituting these values in the appropriate places for x and y within that form. What I mean by that, if I take this first ordered pair, substitute 18 in for y, I have 18 equals, substitute x in as -3, it'd be a times -3 squared plus b times -3 plus c. If I simplify that, 18 is going to equal be 9a minus 3b plus c. Now, we don't want to have these other points feel neglected, do we? We should use them as well. Plug those into our general form. Y is -9 for this second point. X is going to be 6, so a times 6 squared plus b times 6 plus c, where if I simplify that, that -9 equals 36a plus 6b plus c. For good measure, let's do the same with the third point. Y now being -57, x now being 12. Simplifying that, I've got -57 equals the 144a plus 12b plus c. So using the given information, these points on my curve, I've plugged in what I can. I've formed 3 equations. Now, if I'm trying to get to this form of y equals ax squared plus bx plus c, I need to know what a, b, and c are. Solving for 3 variables, right? Which means I need a system of equations. And if it's 3 variables, I need 3 equations. So now I got to go back and think about the strategies I have to solve something like this. Right, here's my system right here. So we got some ways we can go with this. One way, the first way we ever learned how to do this was to stack these guys, do some elimination. We did determinants as well, right? We worked with matrices, so Kramer's rule would be fair game here. I'll be honest with you, it doesn't matter, you know, to each his own. Here, eliminating is not too bad, because notice the c's should be pretty easy to cancel out, right? So if I call this stack A, this stack B, this stack C, and I stack, say, A and B, or if I got too many A's and B's floating around, because you are solving for A, B, and C here. If you want to choose other variables, choose other variables. But by saying I stack A and B, that means I'm stacking the first 2 equations. I'll take 18, set that equal to the 9a minus 3b plus c. And if I know the c's are going to cancel out here easily, let's go ahead and adjust the signs for the second equation. Let's make this 9 equals -36a minus 6b minus c. So I've already multiplied that second equation by -1. Allows us to go through, cancel out those c's, meaning you've got 27 equals -27a minus 9b. So I stacked the first 2 equations. Usually what we did next was we stacked the second 2. So by b and c here, I'm stacking equations 2 and 3. Got to eliminate the same variable as what I eliminated over here, so we'll eliminate c again. If I write out the second equation, if I leave that as is, and then adjust the sign on the last equation, it'd be 57 if I multiply everything by -1, be minus 144a, be minus 12b, minus c. So c's will cancel. If I add through now, you got -9, 57, so 48. You got -144 and 36, so that's -108a, right? -12, +6, -6b. So far, so good. What you've created now, you've created two new equations with two remaining variables. You take those two, you can stack those together. So let me transfer this over. All right, so transfer them over, stack them again, eliminate again. What do we want to get rid of here? Want to get rid of the b's? Doesn't matter to me. Actually, if you wanted to, you could get rid of the a's by multiplying that top equation by, should be 4, right? All right, 4 times 27, that's 108, isn't it? So, if I make it -4, then that'll adjust for the signs. You've got -108 equal to 108a plus 36b. Bottom equation, we like that already. Should be a double arrow there. So now adding through that, a's are gone. You've got -108, you've got 48, so that's -60. You've got 36 minus 6, so that's 30b. Looks like this is going to work out nice. b is -2. So we find b. We take our b value, plug back in really to any of these equations here to figure out a. And then once we have our a value, we'll go back and we'll plug into any one of these equations to figure out c. Okay, so we've got our a, we've got our b, we've got our c. Goal here, which don't forget what it was because it's been so long, you're trying to write this equation in the quadratic form. So our answer is going to be y equals a, which is -1/3, x squared, plus, actually be minus, right, because it's a -b, minus 2x plus c, 15. There's our answer. That's our quadratic that contains the 3 points we started with.